Now this is the another video that is about the differentiation. We have already seen that what are the function may be the linear or quadratic or cubical or many more. Let's go straight to the differentiation. Let's say we have a function which is quadratic or parabola in a nature, and this is our fx and this is our x. In the y-axis we have the output of the function, and let's say for this function this quadratic equation is like x square. This function is, I said, we have already discussed that quadratic function gives a parabolic graph which is like x square or 2x square or 3x square plus 5. In that manner the degree of the polynomial has to be always 2, and we want to know how much change will occur in our fx or y when we make particular change in our x. So let's say this is the x we have taken at this particular point. At this x there must be a particular value for this y, which is fx. And further, if we make an increment in our x, that is this part, this increment in our x is like h. This increment is h. So this part becomes x plus h. Earlier we had x, and now we increasing this part by h to get this thing like x plus h. And then what is our function? The function becomes f x plus h. F x plus h. What do you mean here by this? We want to know that how much of change in x gives how much of change in y we get. How much of change in x, what is the change in y we get, because it is a quadratic function and the quadratic function is parabolic. So parabolic makes always a 2 difference. I mean, when you make a little bit of the run, the rise is too big because of the power 2. So this h indeed is a very small, and we can understand this h. For example, you have 1 lakh rupees, and with 1 lakh rupees somebody give you 1 rupees more, or say 10 paisa more. This 10 paisa is almost negligible in front of this 1 lakh rupees. The 10 paisa has no worth, In the same case, when this x is a good enough, that h we are making increment is a very small. Well, we can see the gap is too wide over here, but this is not actually noticeable wide. This is too much. And well, what is a differentiation? A differentiation is nothing but change in y with respect to change in x. I'll call this is also our tan theta, and because, well, we know that what is tan theta? Tan theta is equals to perpendicular over the base. That is tan theta. If this is theta, perpendicular over the base, that is the normal mathematics we can see. And well, what is happening over there? Actually, we are getting the change in y with respect to change in x. Change in y with respect to change in x is nothing but the theta, and that theta is tan theta here. Why? Because it is perpendicular over the base. Differentiation is tan theta. Tan theta is what? The change in y over change in x with respect to change in x. While making a small change in your run, how much rise actually we getting, how much change we are getting in the y. And this in mathematically term, we also refer this as m. Is just a slope, kind of a slope. So it is our and well, here when say differentiation of dy by dx here is, you can see what is our limit, how much we limit, what is the limit of our x when limit h tends to 0. That I already told you, this h has to be very small, very small compared to this x, so which turn to be smaller and smaller, not actually 0, tending to be 0, not actually very much 0, but as I told you, this 10 paisa in front of 1 lakh is almost like nothing. So it's the same thing here. We see that while making this h change in our x, this h in front of the compared to this x is very small, and that's why we are writing here when h limit h tend to 0. And what is our fx here? Fx, the change in y. What is our change in y? That change in y is this over this, that is this over this much over this much. How much y has been changed compared to this y? So this is fx plus h minus fx over, what is the change of x? Change of x is this minus this, final minus initial. What is your final? Final is x plus n, and what is your initial? That was x. So when limit h tends to 0, when limit h tends to 0, the fx plus h for this equation we have, for this polynomial we have here, is fx plus h square. Actually we making change in our x, so that is over here is our function is not x, actually it is x square, so we are changing x plus h square minus fx square divided by this x plus h minus x. And well, these two x are finished as they have the reverse sign. And next, limit h tends to 0. Here we have x plus h square minus x square over h, and here we can see that now we are left only with these algebraical expressions over here. We have to solve this, and we will finally get what is the differentiation in this portion. Well, I can solve it over here. You see, we have x plus h whole square minus x square over h when h tends to be 0, means h is not actually 0, it is actually limiting to be 0. Very small changes there. Well, you can factorize this one, and that is a square plus b square plus 2ab minus x square over h. These two x square got finished, and what we are left with? Well, I have to go into the next page. Here we have x plus h. I'll resolve this one, minus x square over h when limit h tends to 0. On solving this one, we get x square plus h square plus 2xh minus x square over h, and these two x square gone. Limit is still existing, that is h tends to 0. So some maybe get confused with this limit. Actually, if you have not done this earlier and you have not gone through what is the limit is nothing but you are actually limiting your change in x, which is very smaller. Being parabolic path, we have to make that h very small. Now limit h tends to 0, take h as a common, and then we have h plus 2x over here divided by this h and h get finished. Limit h tends to 0, h plus 2x. Now we can put the value of this h over in this equation, and 0 plus 2x, the final answer is 2x, and that is the differentiation of x square. That is the differentiation of x square. And how we do understand this one is that while making this is a parabolic path, and while making very small change in our x, very small change like from here to here, next one, how much rise we get, how much run and rise, that change in y over change in x, change in y over change in x, and that ratio is 2x. That ratio is 2x. We'll be coming with a more and more differentiation, more and more technical handling with the physics and mathematics. Thank you.